Aloha, you marvelous mathematicians. Let's get into today's lesson, which is going to be all things dilations. So our four vocab, we've got number 2, dilation. It's going to be a transformation that enlarges or reduces a figure. Easy peasy. Figure on a coordinate plane, a figure not on a coordinate plane, just the dimensions, whatever. It's just changing by enlarging or reducing. We have number 8. We dilate using a scale, which is the ratio between two sets of measurements. Sorry, I was actually confused that with scale factor. Which is the ratio used to enlarge or reduce similar figures. A scale is the ratio between two sets of measurements. A scale factor is a ratio used by multiplication. Let's add that in there. By multiplication. Multiply. If you could fit the whole word multiplication on there, that'd be great. Similar figures, you all know that from 7th grade. These are figures with the same shape, but not the same size. So like the same angle measurements, not the same lengths because they're not the same size, but they are similar figures. Their lengths are proportional. Cool. Go ahead and flip to page 10, I believe. Yeah. All right, so to start off, let's quickly review what a scale factor is. Harold and his friends went to a wizard camp. That's cool. They took a class on spells and potions. The group tried several potions that would either cause them to grow or shrink based on the scale factor of that potion. So mathematically, let's figure out what's going on here. So the first one's done for us. I love that. So our starting height is 60 inches. That was horribly done. And our scale factor is 1/2. So they multiply by 1/2. Got 30 inches, and because 30 is smaller than 60, he shrunk. That makes sense. So mathematically, this should be easy. All I'm doing is multiplying, right? So I'm starting at 64, scale factor of 3. I multiply. Now he's 192 inches. That is much larger than 64, so this is a grow. Boom, that's easy. All right, starting height, 56. Scale factor, multiply by 1/8, which is the same thing as just dividing 56 by 8. Which comes out to 7, which is much, much smaller, right? 7 is much smaller than 56, so this is a shrink. Easy peasy. How about y'all finish the rest on your own, right? Super easy. All right, how easy was that, right? Got them all right? Super easy. I did change this 3.5 to 1.5 just because I knew that off the top of my head. The 1/8, I did not know off the top of my head, but I think it's 0.125. I think. But I wasn't sure, so I just wrote 1/8, and I know 56 divided by 8 is actually easier math than multiplying 56 times 0.125. It's actually quicker than even typing in my calculator, but I digress. All right, what do you think would happen if someone drank a potion with a scale factor of 1? Well, I'm thinking absolutely nothing. All right, so let's look at scale factors that cause Harold and his friends to grow. Well, that was a scale factor of 3, 2.5, and 1.5, which all of these scale factors, all these guys, are greater than 1. List of scale factors that cause Harold and his friends to shrink. That is the 1/2, 1/8, 0.4, and I believe that's it. And of course, all these guys are smaller than or less than 1. The magical formula, or how we set it up, which is also not new, because we did this last year, new over original. Or you could say image over pre-image, right? Because pre-image is the one without the apostrophe. Image is a copied, already transformed image with the apostrophe. Yeah. If the scale factor is greater than 1, it will grow or enlarge. If the scale factor is less than 1, it will reduce or shrink the figure. Furthermore, a dilation, which is what I guess the verb is, what we're doing to the figure is a dilation, and we're using a scale factor to do that. We enlarge or reduce, depending on the scale factor. To dilate a figure is basically just multiplication, which is what we did at the top, right? All we did was multiply the number times the scale factor and got the new number. Cool. Let's flip the page. Let's keep going. We're sailing. This is easy. All right, here is my rectangle. I am dilating each figure, each rectangle, by the given scale factor, and then recording the new dimensions. So I have a rectangle. This is 15 by 35 currently. 15 by, which is what we do with the multiplication sign, 15 by 35. All I'm going to do here is take 15. Let me zoom in. And multiply by 2.5. I'm going to leave it as a fraction and not change it to 0.4 and not even type it in my calculator because this is easy. I like to cross reduce. Taught you guys this last year. I'm reducing both numbers by the same factor of 5 and then just multiplying. 3 times 2 is 6. Same thing with the 35 times 2/5. I'm going to reduce it. 35 divided by 5 is 7. 7 times 2 is 14. And again, this is 6 inches by 14 inches. Is my new rectangle, which is much smaller because 2/5 is smaller than 1. Less than 1. Cool. I'm going to have you guys try the next two on your own just because this is that easy and I feel like you can do it. Just type in the calculator or try your mental math skills with this fraction one. See if you can cross reduce. Cool. There we have it. I just went in and added next to scale factor if it was enlarging or reducing. And of course, the first one was the only one that was reducing because my new dimensions are smaller than my original dimensions. But for the others, the new dimensions are larger, so it's an enlargement than the original dimensions. And I really hope you tried the mental math with the fractions. Just because I feel like it's easier. 24 divided by 3, 8 times 5, 40, done. 30 divided by 3, 10 times 5, 50, done. Easy peasy. All right, now we're going to find the scale factor. So we're doing the opposites. So instead of multiplying the scale factor times the original numbers, I am actually going to use the original and the new numbers. All right, so these are this is the image. These are the original numbers. And the new, oh shucks, you know, I did what a kid would do. The original is always the pre-image. It's the pre. And then the new is the image, the copied. And it's the one with the apostrophe. All right, I have to choose sides that are proportional. So I'm going to choose 15 and 12 and 15. And to set this up, it is always new over original, which again is not new. Y'all have heard that before. We did this last year. So I have 15 new over 12 original, and I'm just going to reduce this. Reduce it both by a common factor of, what, 3, right? 3 can go into 15 5 times, 3 can go into 12 4 times, oh, 14, what's that, Palmer? Stupid. 4 times. Or we can say this is 1.25, right? If we use a calculator, which is fine, we can do that. Easy, new over original. But again, they have to be proportional sides. And how did I know that these guys were proportional? Well, because they're both the side lengths that are between G and I, right? All right, go ahead and try this guy on your own. Well, I bet you can do this. Actually, I know you can because you're amazing. 8 over 12, reduce it, 2/3, 0.66 repeated, done. And actually, guys, that's it. That's the end. So if there was anything in this lesson that you didn't understand, please reach out to your teacher because clearly it's our job. Let us help you. You don't want to move on and still not understand this. But I feel like this is good.